Yeah, here's the session number 17, section 2.6, implicit differentiation. Implicit differentiation means you're going to take the derivative of a function that is not directly defined in terms of x. So let's consider two equations, y equals x squared and y squared equals x. The first equation we would say is defined explicitly in terms of x. In other words, it's very clear what y is in terms of x. While the second one is defined implicitly, in other words, it is implied in terms of x, that y equals either the square root of x when you solve that equation for y, or y equals negative square root of x. In this case, it's easy to find what y equals by solving for y in terms of x, but this may not always be the case. We can think of y squared equaling x, where y is some function defined in terms of x, which we may or may not know. This is similar to using the chain rule and having y of u, where y of u is some function of x, which we substitute in later. So implicit differentiation involves using the chain rule. Let's take the derivative implicitly of y squared equals x. Look at the left-hand side of the equation and use chain rule, okay? But y is some unknown function defined in terms of x. So that would be like what we let u equals in the chain rule, okay? So the derivative of that, if it was u squared, we would say is 2u. But we're not going to use u, we're going to use y. So in this case, it's just 2y. Okay, but the chain rule says that the derivative of dy dx is equal to the derivative of the outside times the derivative of the inside. So 2y would be our derivative of the outside, and we would have to multiply that by the derivative of the inside function. We don't know what y equals, so we're just going to call it y prime. So the derivative would be equal to y prime. Therefore, the whole derivative of our left side would be 2y times y prime. Derivative of the right-hand side with respect to x would just be 1. Okay, in steps, remember, break things down into steps. It's a lot easier. For step 1, take the derivative of both sides with respect to x. So y squared equals x is our equation. We take the derivative of the left side, which I just said, 2y, the derivative of the outside function, times y prime, the derivative of the inside function. Derivative of x would be 1. Step 2, solve for y prime, which is actually dy dx. Y prime equals 1 over 2y. Okay. Step 3, which you can do if you know what y equals, you would substitute what y actually is in the answer. In this case, y equals plus or minus the square root of x. So y prime would be equal to 1 over 2 square root of x, or negative 1 over 2 square root of x. Notice, if you were able to solve the original equation, y squared equals x, for y, and took the derivative, you would get these two answers. But like I said, a lot of times you don't know what y is, you just want to find what the derivative is, and then plug values in the derivative to find its rate of change. Here's another example which I've done on paper for you. Okay, this one's a little more complicated, so we'll go through it slowly. Find dy dx if y squared equals x squared plus sine of x times y. Notice right off that sine of xy is the sine of a product of two functions, x times y. We don't know what y is, that's okay, but we're going to have to use chain rule there to find that derivative. Okay, step 1, take derivative of both sides, WRTX. WRT stands for with respect to. Okay, derivative of the left-hand side would be 2y, y prime. We don't know what y is, it's like our u. And in this case, we don't know what u equals. Derivative of the right-hand side is 2x plus, I'm sorry, I haven't taken the derivative. It would be 2x plus sine of xy. We need to find the derivative of sine of xy, which I'm going to represent as the derivative of the sine of xy dx. We have to use chain rule to find this part of the derivative. Let u equal xy. Du dx would be x times y prime, the derivative of y, plus y times the derivative of x, which is 1. Okay? Y of u, if u is x times y, would be the sine of u. Dy du would be the cosine of u. So therefore, the derivative of the sine of xy with respect to x would equal dy du times du dx. That's using chain rule. Substituting in, it would be equal to cosine of u times the quantity x times y prime plus y. Okay, continuing on, left-hand side, 2y prime equals 2x times, substitute what u is into cosine of u. Cosine of x times y times the quantity x, y prime plus y. Step 2 is on the next slide. Get y prime by itself. So the first line here is exactly what we ended up on the previous slide. Okay, now what I'm going to do is I'm going to distribute cosine of xy across the brackets of xy prime plus y. And you get 2y prime equals 2x plus cosine of xy times xy prime plus cosine of xy times y. Okay, keep in mind we're trying to isolate y prime. Okay, so what I'm going to do now is I'm going to subtract over the cosine of xy times xy prime to the left-hand side. You get 2y prime minus the cosine of xy times xy prime equals 2x plus cosine of xy times y. Okay, now what I'm going to do is I'm going to factor out the common factor on the left-hand side of y prime. Y prime times the quantity 2y minus cosine of xy times x equals, don't change the right, 2x plus cosine of xy, y. Solving for y prime, I'm going to divide through by the quantity 2y minus cosine of xy times x, and I get y prime equals 2x plus cosine of xy times y all over the quantity 2y minus cosine xy x. Now, I cannot find the derivative with just one value of x. But if you give me a value of x and y, okay, I can tell you the rate of change of that function. And I can do that without even knowing what the original function y was, which is pretty cool. Okay, this is what implicit differentiation does for us. But I would have to know a point xy to stick into y prime. Here's another problem, maybe a little bit easier. Find dy dx if y squared equals x minus x plus 1. Again, follow your steps. Step 1, take derivative of both sides with respect to x. So that would be 2y times y prime equals, got to use quotient rule on the right-hand side, x plus 1 times the derivative of x minus 1, which would be 1, minus x minus 1 times the derivative of x plus 1, which would be 1, all over bottom squared, which is x plus 1 squared. Okay, now we're going to do some algebra. I need to solve for y prime. So all I have to do is divide both sides by 2y. So what I get is x plus 1 minus x plus 1, I distributed the negative sign, all over x plus 1 quantity squared times 2y. Simplifying the numerator gives me 2 over x plus 1 quantity squared 2y. For your practice problems, I want you to look at pages 204 to 205, numbers 1 through 26. I also want, as part of your assignment, to go on Edmodo and either post 2 questions that you don't understand or answer 2 questions or any combination of posting and answering that adds up to 2. Everyone needs to do this. Thank you and see you in class on Monday. Bye.